This is a hands-on class, so grab the lab guide and follow along. Over the last 2 classes, you learned to make an API call and read the whole response object, and 822 how, the content, the stop reason, the token usage. Today, we take 2 of those pieces and turn them into real production quality behavior. First, streaming. Instead of waiting for the entire reply and then showing it, we stream the words out live as Claude writes them, so your app feels instant and alive. Second, handling stop reasons properly. We make sure we always know why Claude stopped, so we never accidentally show a user a half-finished answer. These 2 skills, and A2I, to all, streaming for responsiveness, and stop reason, handling for robustness, and A2I, 2I, are exactly what separate a toy script from something you would actually put in front of users. By the end, you will have built both. Let us get hands-on. Here is what we will build today. First, why streaming matters. Second, the life cycle of a stream. Third, the event types a stream sends. Fourth, how to consume the stream in code. Fifth, stop reasons and how to handle them. And sixth, the patterns that make it all robust. Let us begin. Let us start with the why, because it reframes how you think about a response. Without streaming, the experience is this. The user asks something and then stares at a blank screen while Claude generates the entire reply behind the scenes. Only when the whole thing is finished does it appear, all at once. For a short answer, that is fine, but for a long one, that can be several seconds of nothing and 85 pool, and several seconds of nothing feels broken, like the app has frozen. Users hate the wait even when it is short. With streaming, the words appear live, the moment they are generated, an 8212 half. That familiar typing effect you have seen in chat apps. The user starts reading immediately, watches the answer form, and never doubts that something is happening. The crucial insight is that the total time to finish is exactly the same either way. What changes is entirely the experience. Streaming does not make Claude faster and A212. It makes the app feel instant. That is a huge return for a small change. For anything, user-facing streaming is often the single biggest improvement you can make to how your application feels, and it costs you only a slightly different way of handling the response. It is the difference between an app that feels like it is thinking with you and one that feels stuck. So the takeaway, without streaming, a user waits at a blank screen for the whole reply, but with streaming, the words appear live and A2 half. The total time is the same, yet the experience is transformed, which is why you stream anything user-facing. So how does streaming actually work? Instead of one big response, you deal with a flow of small pieces over time. Let us walk the life cycle. First, you open a stream. When you make the request, you ask for the reply as a stream rather than as a single response. This tells the API to start sending you the answer in pieces as it is produced, instead of holding it all back until the end. In the SDK, this is usually one small change to how you make the call. Then, the deltas arrive. A delta is just a small chunk of the reply and 8012, often a few characters or a word and 8012, delivered live as Claude generates it. Rather than one response, you receive a steady sequence of these little chunks, one after another, in real time. This is the stream in action. And finally, you assemble. As each delta arrives, you append it to a growing string, building up the full reply piece by piece and 8112, and you show that growing text to the user as you go, which produces the live typing effect. When the stream ends, your assembled string is the complete answer. Open, receive deltas, assemble. That is the whole shape. So the takeaway, streaming means you open a stream, receive many small text deltas as they are generated, and assemble them into the full reply, and 8021, you handle a flow of pieces over time instead of one big response. To consume a stream correctly, it helps to know the kinds of events it sends, because it is not only text and 8112, there are markers around the text too. First comes a message start event. This signals that the reply is beginning. It arrives before any text and lets your code setup and 8200 pod, clear display, show a cursor, get ready to receive content. Then, come the content delta, events, and AT12, the heart of the stream. These carry the actual text of the reply, chunk by chunk, and there will be many of them in a row, each with a small piece of the answer. This is where the words you show the user come from, and where you spend most of your handling logic. Take the delta and ini first text, append it, display it, and finally, a message stop event signals that the reply is complete. No more text is coming. This is your cue to finalize and 8U4, stop the typing cursor, and, importantly, read the stop reason to learn how the reply ended, which we will get to shortly. So the pattern is a start marker, a run of content, deltas carrying the text, and a stop marker at the end. Knowing these three kinds keeps you from being surprised by the non-text events in the stream. So the takeaway, a stream sends a message start event, then a run of content delta events carrying the text chunk by chunk, and finally a message stop event in A2112, a start marker, the content, and an end marker. Now the actual code pattern and 8125, and it is pleasantly simple once you see it. This is the core of today and 939 Salab. First, you loop over the events. The SDK gives you the stream as something you can iterate, and A212, a loop that yields each event as it arrives. You write a loop that runs once per event, processing them in the order they come. The loop naturally pauses between events, waiting for the next chunk, so your code stays in step with the live stream. Second, inside the loop, you build the text. For each content delta event, you take its piece of text and append it to a string you are accumulating. And right there in the loop, you update your display with the new text and 8512, printing it or updating the UI element and 8512, so the user sees it appear live. That is the entire typing effect. Append and show, append and show on every delta. That is genuinely most of it. Open the stream, loop the events, append each delta to your growing answer, and refresh the display as you go. When the loop ends, you have both the complete assembled reply and the knowledge that the stream is finished. The lab walks you through this exact loop in code, and 812. It is short. And once you have written it once, streaming becomes second nature. So the takeaway, consuming a stream is a loop over its events where you append each content delta to a growing string and update the display as you go, and A212, that append and show loop, is what creates the live typing effect. Now, the second half of the class, an ATY, on a habit that prevents a whole category of bugs. When the stream ends, you must ask why it ended. The happy case is end turn. This means Claude finished naturally and A2812. It said everything it meant to say and stopped on its own. When you see end turn, the reply is complete and you can trust it fully. This is what you hope for on every call. The case that catches people out is max tokens. This means Claude did not finish and A212. It ran into the length cap you set and was cut off, possibly mid-sentence. The stream ended, the text came through fine, but the answer is incomplete. Nothing errored, it just stopped early because you did not give it enough room. So the rule, whether you stream or not, is after the reply ends, always read the stop reason before treating the reply as done. This is the single check that stops you from confidently showing a user a truncated, half-finished answer. It takes one line, and skipping it is one of the most common mistakes people make with the API and 82112, a summary that trails off, a piece of code missing its last lines, all because nobody checked why it stopped. So the takeaway, when the reply ends, always read the stop reason, and A212, end turn, means Claude finished, and you can trust it, while max tokens means it was cut off, and the answer is incomplete. So never treat a reply as done without checking. Let us name the specific stop reasons you will actually handle, so none of them surprises you. End turn A212, the reply is done. Claude finished naturally. This is the normal, complete case, and most of your replies will end this way. Max tokens and AT12, the reply was truncated because it hit your length limit. The answer is incomplete and needs handling, which is the next slide. And too loose, an 8-tool wall. This one means Claude wants to call a tool to help answer, rather than finishing with text. You will meet this properly in a later class on tools. For now, just know it exists, so that when you see a stop reason that is neither enter nor max tokens, you are not baffled and 82 hours, it is Claude asking to use a tool. Handling these three by name and 80 or 12. Done, truncated, wants a tool and 80 or 12 covers what you will encounter, and writing a simple branch on the stop reason is exactly what the lab has you do. So the takeaway, the stop reasons you will handle are end turn, finished, max tokens, truncated, and too loose, Claude wants a tool, covered later. And A212 view, branch on these, so every ending is handled deliberately. Let us deal properly with the tricky one and 80-112. What to do when the stop reason is max tokens and your reply came back unfinished. The first rule is, do not just show the half answer. A truncated reply that trails off mid-thought is a bad experience and, for things like code or structured data, can be outright broken. Recognizing max tokens is precisely so you can avoid presenting incomplete output as if it were complete. You have two good options. The simpler one, raise the max tokens limit and make the request again, giving Claude enough room to finish this time, and 8 useful when you underestimated how long the answer needed to be. The more elegant one, take the partial reply you already have, send it back as context, and ask Claude to continue from where it left off, and 82 effectively stitching the full answer together across two calls without wasting the first. Which you choose depends on your situation, and the lab shows both. The key mindset is that max tokens is not a failure to fear, but a condition to handle. A robust application treats it as a normal branch in the logic, detect it, then either retry with more room or continue the message, so the user always ends up with a complete answer. So the takeaway, on a max token, stop the reply is incomplete. So never show it as is an 8200 fall. Instead, raise the limit and retry. Or feed the partial back and ask Claude to continue, so the user always receives a whole answer. One more piece of robustness. Because streaming introduces a failure mode that a single response does not end A212 well, the stream can break partway. The risk is that a stream is a live connection held open over time, and live connections can drop. A network hiccup, a timeout, a lost connection can cut the stream off in the middle of the reply, before the message stop event ever arrives. If your code assumes the stream always completes cleanly, a midstream drop will crash it or leave it hanging. So you recover gracefully. Wrap the stream consumption in error handling that catches a broken connection. When it happens, you still have the partial text you accumulated up to that point, and 85 vol. Do not throw it away, and 85 vol. And you can retry the request or continue from the partial, just as with a truncated reply. The goal is that a dropped connection becomes a handle bump, not a crash. This is the difference between a demo and production code. In a quick script, you might ignore the possibility. In a real application, serving real users on real networks, streams will occasionally break, and the ones that handle it keep working while the ones that do not fall over. The lab has you add this error handling around your streaming loop. So the takeaway, a live stream can break mid-reply, so wrap it in error handling and 8-212. Cache the drop, keep the partial text you already have, and retry or continue end A212, turning a broken connection into a handled event rather than a crash. Let us close with the checklist that turns everything today into a dependable pattern you can reuse on every project. First, stream any reply that a user will watch appear. For interactive, user-facing responses, streaming is almost always worth it, and 8-112, the responsiveness gain is large and the extra code is small. Reserve non-streaming for background calls, where nobody is waiting on the words. Second, always check the stop reason before treating a reply as done, streamed or not. Make it an automatic step. The reply ended, so look at why. That one habit prevents the silent truncation bug that catches so many people, and it costs you a single line. And third, handle stream errors and 82-112, keep the partial and retry cleanly. Assume that over enough calls, some streams will drop, and write your loop so that when one does, you recover with the text you have rather than crashing. Stream for feel. Check the stop reason for correctness, handle errors for reliability. Those three together are production-grade streaming. So the takeaway, stream user-facing replies for responsiveness. Always check the stop reason before trusting a reply, and handle stream errors by keeping the partial and retrying, and A200Y. Those three habits make your streaming robust enough for real users. Let us gather the whole class in one breath. Stream replies, so they appear live and A2 the same total time, but a far better experience. The lifecycle is open a stream, receive deltas, and assemble the full text. The events are a message start, a run of content deltas, and a message stop. Consume it with a loop that appends each delta and updates the display live. Always check the stop reason and A200 and turn is complete, max tokens is cut off. And stay robust and A202 have. Continue a truncated reply and recover from a broken stream. Next class and AT12, system prompts and shaping how Claude behaves. One idea at a time. That is streaming and stop reasons and A2112, the two upgrades that make an API call feel and behave like real software. Stream the reply and your app feels instant and alive. Read the stop reason and you never ship a half-finished answer, handle the errors, and a dropped connection is just a bump. Walk through the lab guide and build both into a small app of your own and A2 Once you have, you will use these patterns in everything you make with Claude. We will see you in the next class.